These are the lesson 1.6 extension notes. This is the last section in chapter 1 where we are reviewing adding and subtracting fractions using a common denominator. You should have learned how to add and subtract fractions in 5th grade, and the 6th grade content is learning to multiply and divide fractions. So this is a review of adding and subtracting. So the key idea is to recall that you can add and subtract fractions that have unlike denominators by writing equivalent fractions with a common denominator. So in order to add fractions, first you have to have a common denominator. They have to have a denominator that is the same. And so we're going to rewrite those fractions as equivalent fractions. When you hear equivalent, you can hear the word equal in there. So a fraction that is the same just has a different form. So we're going to learn 2 different ways of doing that. You can do it by finding a common denominator by multiplying the denominators. Right? So if I look at 5/8 and 1/6, those do not have a common denominator. You've got 8ths and 6ths. So in order to add those together, I have to find a common denominator. One way to do that is by multiplying 8 times 6 and making a denominator of 48. Bring down the plus sign. And I can ask myself, how many times does 8 go into 4? Well, it goes 6 times. So 6 times 5 is 30. And 6 goes into 48 8 times. 8 times 1 is 8. Right? And then I can add the numerators together now that I have a common denominator. 30 plus 8 is 38. And then especially if you are working in big ideas, you always have to simplify down to lowest terms. So I'm going to divide by, recognize that both of these are even. So I can divide by 2 over 2. When I divide by 2 over 2, that's just one whole. So I'm not changing the amount. I know that anytime I divide something by 1, I get the same amount, but I'm going to change the way it looks. 38 divided by 2 is 19. And 48 divided by 2 is 24. And because 19 is a prime number and it doesn't go into 24, I know that that's finished. Right. Let's look at 3/4 and 5/6. I can start by multiplying 4 times 6 to get a common denominator of 24. And then 4 is going to go into 24 6 times. Then I can multiply this way. I can go 6 times 3 is 18. 6 goes into 24 4 times. 4 times 5 is 20. And now I've got 18 plus 20 is 38 over 24. Let's simplify first. You will need to make this into at least a simplified fraction. So do it the same way we did above and divide both sides by 2. Sorry, the numerator and denominator both divided by 2. And again, we have 19, but this time it's 19 divided by 2 is 12ths. Okay, for Miss Who's purposes, you can always leave it like this unless the problem specifically asks you for a mixed number. Sometimes the context of the problem will lend itself to a mixed number, but for me, this is always okay. If it does ask for a mixed number, then I ask myself, how many times does 12 go into 19? Well, it goes one whole time. 1 times 12 is 12. And then it's going to leave me with 7/12 left over. Okay. 1 and 7/12. Either of these answers is acceptable. Right, let's look at a subtraction problem. I've got 5 and 3. So when I multiply those together, I have 15 minus 15 here. 5 goes into 15 3 times. It's like this. 3 times 3 is 9. 3 goes into 15 5 times. 5 times 1 is 5. 9 minus 5 is 4/15. And then I ask myself if there are any common factors. We're back to that idea of greatest common factors. Are there any common factors for 4 and 15? Well, 15 is not even, and 4 doesn't go into 15, so they do not have any common factors, and that won't simplify, right? Remember that you can use your multiplication chart to look for common factors. You could find, go down the 4 row and the 15 row and see if there are, go down like that and see if there are any numbers that are the same in both rows. Right, you have 3 U-tries to finish. All right. Second strategy would be to find the LCD, the least common denominator of 2 or more fractions. The LCD is the least common multiple of the 2 denominators. The LCD provides another method for adding and subtracting fractions with unlike denominators. You don't have to use the LCD. You can use the common denominator by multiplying the 2 together. In some ways, that's easier because it always works the same way. And if we look at, but when we get to B, maybe we'll see why an LCD is a good option. Right? So for the first one, this is the same problem that we just did, but this time instead of going 8 times 6, this time I'm going to look for the least common multiple of 8 and 6. So if I'm counting by 8s, we go 8, 16, 24, let's see, 4 times 8 is 32, and it would just keep going. And then if I'm counting by 6s, I go 6, 12, 18, 24, and right there is the LCD. Right? So the LCM, least common multiple, and the LCD, the least common denominator, are the same thing. It's just different ways of saying the same thing. So now I can use 24 and ask myself, how many times does 8 go into 24? I have to multiply 8 times 3. So we would multiply 5 times 3 to get 15 here. And on this side, 6 goes into 24. See, 8 went in 1, 2, 3 times, and 6 goes in 1, 2, 3, 4 times. So on this side, I'm going to multiply by 4/4. 6 times 4 was 24, and 1 times 4 is 4. And now I can add, and I've got 19/24, which is the same thing. So I've got 19/24 there, and I have 19/24 here. So in our first example, we used a common denominator by multiplying, and then we had to simplify at the end. If you use the least common denominator, lots of times when you finish, you won't have to simplify at the end. That'll give you a simpler answer. So either way, you're going to have to simplify. It just depends on whether you do it before, at the beginning, or at the end. All right, now look at, what if you have a problem like 13/21 and 9/14? If you use that common denominator method, you're going to have to multiply 21 times 14, and you're going to have a really big number. It's going to be really cumbersome and hard to work with. But if I used the LCM method, then I can kind of count by, I can do 21, see, 2 21s is 42, and 3 is 63. Let's see if that works. There's 21. All right. And then 14, if I count by 14s, that's 14. And then 2 14s is 28. And 3 times 14 is 42. Yay! There's the LCM, which is also the least common denominator. I'm going to grab my calculator just so we could see how big this would be. What if I had to multiply 21 times 14? I would have a denominator of 294. That's a really big number, where if I find the LCD or LCM, I get to work with 42. I think this is easier. Right, so I'm going to multiply times 2. 21 times 2 is 42. 13 times 2 is 26. And I see 14, 1, 2, 3 times 3 over 3. 14 times 3 is 42, and 9 times 3 is 27. And then when I add these together, I know 6 and 7 is 13. This must be 53. Maybe I should have put it out there. 53 over 42. I think 53 is prime. Let's simplify it into a mixed number and see if that's a little easier to work with. If I do 53 divided by 42, 42 goes into 53 one time. 1 times 42 is 42, and that's 11. So I've got 11 over 42, and I know that 11 will not go into 42. That's as simple as it goes. All right, so you can leave it like this, or you can do 1 and 11 over 42, depending on the problem. All right, let's do one more. You could either multiply 18 times 9, or you could recognize that 9 goes into 18. So this must be the least common multiple or least common denominator. If one number goes into the other number, then you know you want to use the bigger number as the LCM. That's way easier than multiplying them together. All right, 18, and this is just a 7. Oh, sorry, that's a minus. I'll fix that. Okay. And then 9 times 2 is 18, and 2 times 2 is 4. And when I subtract, 7 minus 4 is 3 over 18. And again, you always have to check and see if there is a greatest common factor. There is a common factor because 3 goes into both of those numbers. So I'm going to choose 3. Gives me 1/6. 3/18 is the same as 1/6. Right? All right, 2 few tries on subtraction. And then the last section here is subtracting mixed numbers. Right, we're going to do 2 different ways. Again, you may use whichever way you like. Method 1 is to make these into improper fractions. Deciding. I think I'm going to do these vertically. You may keep them horizontal if you want, or you can change them vertically. But sometimes it's easier to see one way and sometimes it's easier to see the other. So let's do both so you can see. Minus 2 and 3/10. All right, so to change this into an improper fraction, I take the denominator and I multiply it by the whole number. If this is 4 wholes and they're all divided up into fourths, then I've got 4 times 4, I've got 16 fourths, plus 1 more is 17 fourths. 17 fourths. All right. And then 2 and 3/10. 10 times 2 is 20, plus 3. There's a problem there. Okay, 23/10. I still have to have a common denominator. So I'm going to find a common denominator for fourths and tenths. I think it's 20. And so this would be times 5. And this is times 2. 23 times 2 is 46. And let's see, 17 times 5 is 85. Right. And then we can subtract. So now I've got 85 twentieths minus 46 twentieths. Let's do a little side work. 85 minus 46. I should have done side work before, instead of grabbing my calculator. Let's see, I'm going to borrow from the 8 and make it a 7. 15 minus 6 is 9. 7 minus 4 is 3. So I've got, I'm going to subtract. I have 39 20th, which you can leave like this, or you can make that back into a mixed number, 1 and 19 20th. Whew! Subtracting mixed numbers with unlike denominators, borrowing is such a lot of work. Oh my goodness. Okay. Other method is to borrow a 1. So instead of making it into this big improper fraction, you can, so this is or, you can do it 2 different ways, minus 2 and 3/10. I need to change my denominator first, and I should have done that first over here too. Just because if the numbers were kind of like a fourth and 3/10, it's not really obvious which one's bigger. I mean, I think 3/10 is bigger, but it's not clearly bigger. So let's do denominator first. Again, I'm looking for a common denominator for 4 and 20. Or 4 and 10, so I'm going to use 20. All right. 4 goes into 25 times, so 1 times 5 is 5. And 10 times 2 is 20. 3 times 2 is 6. Yeah, so see, I've got 5 20ths and 6 20ths. Those are pretty close to the same size. So change your denominator first, and then you can see, well, I can't subtract 5 minus 6. I need to borrow the same way you do when you are subtracting, right? So I'm going to borrow from the 4 and make it a 3. And then the thing that I'm borrowing is 20 20th. So I'm going to borrow 20, and I've got 5 here. I'm going to have 25 20ths. That trick will always work. When you borrow 1, you can just add this denominator plus the numerator, and that gives you the new numerator. And then this number is just going to come over. And now I can subtract. If I've got 20 minus 6, that's 19. And 3 minus 2 is 1. So I get the same answer. I almost always do it this way. I think that it's easier to borrow than it is to change it into a really big improper fraction. Right? You may do it either way you want, but if you understand borrowing, I think this keeps the numbers smaller and simpler. Okay, and then 2 practice problems to go with that.